Okay, this video is on distance, rate, and time, kind of capping off our unit on independent variables and how to graph them and come up with equations. It's just kind of applying it in a real-world situation of distance, rate, and time. So we started on page 202, sorry, and no, 209. I was right the first time, 209, and we looked at the situation. So the swimmer is having all of her times and distances graphed, okay? And basically, her coach drew a line through the points, and you'll notice it doesn't completely trace it. So we talked about this being the best fit line, all right? So in this case, it says Dezia's little sister thinks that all Adezia's time and distance points should be on the line drawn by her coach. Is she correct? Well, here's the thing. She's not going to swim at a consistent speed every time. So even though, yes, she's swimming at different distances, it's not going to be proportional with the amount of time that she takes. She might swim a little bit slower in some days, and some days she might swim a little faster. Okay, so she won't always swim at the same rate. Okay, but speaking of that, let's find and determine her average swim rate. Okay, so if we take this point right here, which honestly works better than this point because this one's actually on the line. This one's not. All right, and we see that this one is 10 minutes to go 0.5 kilometers. So we wrote that, 0.5 kilometers over 10 minutes. And as you can see, we converted that to 1 kilometer in 20 minutes because I wanted whole numbers here. And then that's kind of what they came up with. 1 kilometer is 20 minutes is our rate. And if she's swimming 1.5 kilometers, how long will it take her to go that far? Well, it's a little bit like our scaling up unit. So if I multiply 1 by 1.5, I need to multiply the bottom by 1.5 to get my answer here. So 20 times 1.5 is going to be 30. All right, so we can do the same thing down here. Now, I had to give students these answers, okay? They were earlier in the chapter, but we didn't spend the time to work on that table. So 2.42 kilometers. How many minutes will it take to swim that far? So we set it up just like we did here, 1 kilometer over 20 minutes, okay? And then we put 2.42 on top, and then question mark, what's this going to equal? All right, so 1 times 2.42 will give me 2.42. So I need to do that to the bottom. 20 times 2.42 equals 48.4 minutes. And then we can do the same thing here, right? And basically, if you see the pattern, basically we're taking our distance and we're multiplying it by 20 minutes. Okay, so 0.6 times 20 is going to give me 12 minutes. And 0.75 times 20 is going to give me 15 minutes. 2.87 times 20 is going to give me 77.4 minutes. Okay, which, by the way, is a very long time to swim. All right? Then we look for a pattern. Okay, and as I kind of pointed out, we're basically multiplying the distance, whatever that distance is, it changed each time, by 20 to get our time. All right? In other words, D times 20 is going to equal T, our time. Now, it says to write the equation to represent the distance D she can swim for a given amount of time. Okay, so in other words, we want to get D by itself. And to do that, we need to divide 20D by 20. And then when I do that, I divide both sides by 20. And I get T over 20 equals D. Okay, which would work. But if we want to get fancy, we could basically put a 1 here in front of the T, slide that T off of the edge here, and so it looks a little bit like this. 1/20th times T equals D. And in this case, that 1/20th is our rate. All right, in other words, I can multiply T times 1 over 20 and I get our distance. And if you take a look over here on this page, look at that. Look at what we have there. We have a 1 over 20. It's the same thing, okay? It's because this is our rate. This is our rate. They should be the same, okay? So to solve a problem like this, 45 minutes, that's going to be our T, all right? So here's R, here's T, multiply those. Here's our D, 2.25 kilometers. All right? Okay, your assignment was this worksheet, all right? In this situation, Jeff's a runner. When he's training for a race, he averages a rate of 10 miles per hour. Keep in mind, that is our rate. Okay, so we're going to substitute that for our r in our equation, d equals r times t. So put the 10 there, and then I'm going to solve and figure out what goes in this formula. I'm going to plug in or substitute these for my t's. Okay, so 0.5 times t, or sorry, 0.5 times 10, and then whatever I get, I write that down in the table, and I do that for each one of them, and then I need to graph it. Now I put time down here because it is our independent variable, right, and distance over here. Okay, and I'm going to graph those points, and then I'm going to answer the question on D. And then don't forget, there is a back, very similar situation, just changing it slightly. Okay, thank you for watching.